Hi, welcome back. This is a screencast on how to import data from Excel into SPSS, as well as how to create new measures and conduct scatterplots, all of which are required for the first part, the first mini project of the quarter. So I have SPSS initiated here, and so what I'm trying to do at this point is to get my Excel data sheet into SPSS. Now, this Excel data sheet has all of the data that I copied and pasted from files that I downloaded from Chicago Health Atlas. If you haven't done that yet, you need to go do that first, okay? Because you have to actually have all of your data in an Excel spreadsheet before this can happen. Moreover, all of your data need to be on the same tab. If you have, if you've basically downloaded all of the spreadsheets and copied and pasted them into one Excel file, but they're all on different tabs, you need to go in and like put them all on one tab. So if you haven't done that yet either, go and do that, okay? So in order to do this, we're going to go ahead and double click on New Data Set. And with New Data Set, we're going to click on File, Import Data, Excel. And with Excel, we're going to open a spreadsheet here, okay? Now, this file data set, that was a file that I used in the first video when I created a data set by downloading files from Chicago Health Atlas. But this Chicago Atlas data set has got actually a lot more variables in it, so I want to work with this today. So I'm going to highlight it and click Open. And here, I'm going to have to make some decisions and make some stuff happen. First, we want to make sure that the tab that our data is on is actually selected. So I actually have two tabs in this data sheet. I have like an About section, but I also have the one that has the data. And you'll know that you have the right tab if when you're looking at it, it looks like a spreadsheet. Whereas if I go to this other tab that has like my About information, it's not great. There's a lot of missing rows here, and so clearly those are notes to myself. Okay, so the next thing, we want to read the variable names from the first row of data. This is going to take that first row of data and count all of the values there as variable names. We want to click percentage of values that determine data type, have it be 95, and ignore hidden rows and columns. Now, it's possible that depending on how you did your data or your data sort of collection, that you perhaps you hid a bunch of rows, and that was actually what happened with my data set. I had hidden rows to make it a little bit easier. I had hidden columns to make it a little bit easier to paste the data into Excel. So I am actually, I'm deselecting ignore hidden rows. If you hid a bunch of rows or columns in the initial spreadsheet, but you want them to be included in your data set, make sure that you have unhidden them or you deselect this ignore hidden rows. If you have not hidden any rows, then don't worry about it. It should be fine, okay? But once you import your data, if it looks a little strange or you're missing variables or rows or something, it's possible that you have actually hidden data on your Excel spreadsheet that you just didn't bring in when you imported it. And then we also want to remove leading spaces from string and trailing spaces from string values. And then we click OK. And this is great because we're getting something that looks like a spreadsheet, especially when we look at the data view. And this is very much like we would be expecting in a data file. Okay, I've got all my variables. I've got Gini coefficients for 3 time periods. I've got per capita income. I've got percentage of a community area with a college degree. We've got percentage of the community area without a high school degree. We've got percentage of the community area that's white, percentage of the community area that is Hispanic, percentage of a community area that is non-Hispanic Black, and then we also have this like one-off social services variable. I'm just, I kind of wanted to see what that was going to look like. I also have percentages of community areas with single parents, and then percentage of community areas with foreign-born residents. So like in this community area, on average, there were 28.4% of residents who were considered foreign born. We also have life expectancy for a handful of years and more infant mortality rates. So that's all my data. Now, the thing is that I haven't saved this data set yet. Okay, this is, you can tell because there's a star up here by Untitled. And we want to save this data set this one time, and that's pretty much it. Okay, so we're going to call this call it IMR data, but you could call it anything. And click save. Okay, so that's cool. I'm going to go ahead and start Xing out of any windows that don't have any data in them. So like this random spreadsheet doesn't have data, we can get rid of that. And then we're left with a data view and a viewer. Okay, now these are the two main sort of default windows in SPSS. One of them shows our data, and we can actually toggle back and forth between variable view and data view. The data view is actually like the data, it's like the on the ground view of your data set. The variable view is like the 1,000-foot view. You're able to kind of look down at your variables and see how they're coded. You can see you can see a lot more of the variables at one time, etc. And then the output or the viewer is this file that basically just kind of prints or reports everything that you do during this SPSS session. Okay, so like whenever you do something, it's going to show up in this window. All right, and that's fantastic. But the real thing that we're looking for today is we want to work with a syntax file. And since we haven't started one yet, we're going to start that. We're going to start with doing that. So if you click on File, New, and Syntax, that gives you the chance to start a new syntax file. Okay, and I'm going to off the bat just go ahead and save it. I might need to make a comment first. Syntax for NSG 481 mini course projects. Okay, so with SPSS in the syntax file or the syntax window, like the one that I'm working with right now, is that if you start a row or a line with a star, SPSS will just ignore everything that comes after it until it sees a period. Okay, and so what that allows us to do is it allows us to comment out certain lines of syntax to help us organize it or to help us like remember what we were thinking when we created a variable. All right, so I'm going to go ahead and just put in this one line so that I can save the syntax. Okay, so we're going to assign this to that. It's in my Dropbox, isn't it? Thanks. So JVR stuff and teaching and course projects. Okay, so syntax. Cool. Okay. So like I said, the syntax, this is really where, this is the sort of meat and potatoes of your project. The data, we can always like replicate your data set if we need to. We can go back and recreate it if you accidentally delete it. The output file is just like a running record of everything you've done in this session. The syntax is where all your work is going to go. All right, you're going to like copy and paste your work into this window. And the reason for this is so that we can have reproducible research. Okay, I'm going to show you a couple of tricks on how to easily create analysis that you're trying to do. But we're going to copy and paste the syntax that's generated from that into this syntax file so that we don't have to keep using the drop-down menu to do this. Okay. Now, the benefit is that once you have all your syntax in this window, it's as easy as selecting all of it and executing it or doing it. And you do that with this green triangle button right here. All right. And in order to do the sort of same steps that you would need to do if you were to use the drop-down menu, it would take a lot more time. Okay. So we're trying to like make this process go easy for us. And this is an iterative process. And we really we don't want to be in a position of always having to start from ground zero every single time we work with SPSS. Okay. So this is the main attraction for us. Okay. If you give me your data and you give me this file, I should be able to recreate all the analysis that you are doing for your project. Okay. All right. So that's great. We're going to start with just some comments in the syntax file to help us stay organized. Okay. And you could also just abbreviate dependent variable with DV. This is going to be, oh, so I can, when I'm in the variable view, I can always go to a variable name and click on the cell and copy it. Okay. And then go into my syntax and paste. Honestly, it is 2020. Please utilize shortcuts from the keyboard. So Control A for select all, Control C for copy, Control X for cut, Control V for paste, mostly because it just is faster and it's an easier way to work. So do use the keyboard shortcuts. All right, so we have that, and then we have IV1, which is, let's do foreign-born. And since I'm using the 2013-2017 data, I'm going to want to, as much as possible, try to use 2013 to 2017. Now, I don't have that as an option. I'm going to have to use 2012 to 2016. So it's not perfect, but it's pretty close. And I would just report that in my limitation section of my paper. Just say that those years don't match up exactly, but they're pretty close. Okay, so IV2 is going to be, we could go single parents. Oh, you know what? I can actually go IMR 2012 to 2016. That's actually probably a better way to do this. Cool, cool. All right. And so we have foreign-born from 2012 to 2016. We've got single parenthood. We've got non-Hispanic Black. Let's go non-Hispanic Black. So this is the proportion or the percent of a community area and then we could go, I'm really interested in this Gini coefficient, mostly because I haven't worked with it before, so let's grab that. And what this is it's a measure of socioeconomic diversity. Oh, I should have said this should be 3. Cool. All right, IV4. Ugh. Let's go per capita income. Okay, and then finally my last independent variable. Let's go, I like the no high school degree or no high school diploma. And that actually is a measure of the percentage of a community area that does not have a high school diploma. Okay. So ultimately, my dependent variable here is the community level infant mortality rates. And what I'm asking with all these other 5 variables are, what are the factors that are related to community level infant mortality rates? Okay, I'm going to do analysis with these because I think that, percent of a community area that is foreign born, percent of a community area that's Black, the Gini coefficient at a community level per capita income, and the percent of a community area that does not have a high school diploma all impact the infant mortality rate in different ways. Okay, so when I ask the question, essentially my research question is something like, we could say impact, we could say effect, okay, so that's my research question. And, these things that I think are related to the dependent variable of, infant mortality rates, we're essentially going to do analysis on these 5 independent variables. Okay. Start by doing a frequency on our variable, the first variable we want to work with. In this case, it's IMR 2012 to 2016. So we're going to go up to Analyze, and we're going to click and drag down to Descriptives and Frequencies. And you're going to pretend like this variable wasn't there. Okay. And basically, you're going to find your variable in the left-hand window. And you're going to click on it, and you're going to click this little arrow button to move it over into the variables window. Okay. We could also select different types of statistics like mean, mode, median, etc. But for right now, we just want to get the frequency. And the whole point behind the frequency is we just want to see what these data actually look like. Okay. So I'm looking at this spreadsheet, and I can tell off the bat that IMR _2012 _2016 has got some crazy formatting here. It's the decimal place is carried out. It looks like 12 or 15 places. So I'm probably going to want to deal with that at some point. I'm not going to worry too much about it right now because that's just annoying. It's not a critical error. It's just annoying. Okay. The other thing to know is that this is a frequency table. Okay. So it tells us all the levels or all the values of our variable that we asked for and how many observations are there. Okay, so there are 3 community areas in Chicago that have an infant mortality rate of 5.80 at this time. And there are 3 community areas that have an IMR of 4.8 at this time period. And there's one that has an IMR of 20.6. Okay, so that is actually kind of useful information. We're going to go ahead and in this syntax window, we want to roll our mouse over it so that this yellow box comes up around it. We're going to double click on it so that we can highlight that syntax, copy, and paste. Okay, we're going to put it into our syntax window. Okay, you want to make sure that you get the period when you do that because the period ends the line or ends the command. And if you don't have a period on there, things happen. So for example, I took the period off of this line and that frequencies right here on line 7, it turned bright red and bold. Okay, that's to tell us that there is a problem with this line or this command. It's that it doesn't end the way SPSS is expecting it. So we're going to throw a period back on there so that everything is copacetic and everything's fine. Okay. So the next thing we're going to do is we're going to make our new variable. Okay, we're going to start with IMR _2012 _2016. We're going to click on the Transform tab and drag down to Compute Variable. Now I already did this and screwed up the screencast on that. That's why you're seeing values already here, but that's not usually how it's going to be. Usually values aren't here already. Okay. So we're going to start by finding the variable that we want to copy or we want to make a copy of, basically. We're going to highlight it, and then we're going to click this little arrow button and move it over into this numeric expression window. All right. Then we're going to go to the target variable window, and we're going to give it a new name. Now, I'm just going to say you should save yourself a lot of heartache here. Don't put in any, like, don't have it be uppercase and lowercase. And don't go all uppercase because it's annoying to look at. Okay. Don't include any spaces here. Don't start the name with a number, which I know a lot of you are going to want to do because we're dealing with year data here. All right. Also, you can't have any spaces. All right. It's very fussy. All right. So let's just go basic, very basic variable here. So IMR 2012, 2016. If you absolutely cannot help yourself and you must have something in here to space out 2012 and 2016, you can do that with an underscore. But again, it's not necessary, okay? We're going to put a label on this in a few minutes and make it look nice so it doesn't look like this ugly thing with no spaces. So once you've done that, click OK. And now you have the syntax for that variable, okay? And we're gonna highlight it, click copy, and then go back to our syntax, okay? And paste, all right? We made sure we got the period here, so it is good to go. Now the next thing we need is we need to label this thing, all right? Now, unfortunately, there's no like good way to do this with the drop-down menu, all right? So we're gonna have to do this like on the fly with our syntax. All right, which is fine. It's all fine. Everybody's going to be fine. Just take a breath and follow along, okay? So we're going to start by, on the line below or 2 lines below the compute command, let's type variable and do this all in caps because all the commands in SPSS are in caps. All the variables are like however we decide to do it. All right, so we're going to go variable. And as we're typing variable, we get, like SPSS is trying to help us with all these options here. Let's go ahead and click on variable labels. Okay. Now here we want to assign a new label to this variable so that whenever IMR 2012, 2016 is used in analysis, it comes out kind of nice and doesn't look like I want to stab myself in the eye. Okay, because if I have to look at a bunch of output with no spaces in the variable names, and it gets really frustrating and annoying to look at. All right. Also, like when I'm done at the end of the day and I put all this into a Word document, I don't want to have to go back to all of my tables and fix that. It's super annoying. Okay, because you guys know what Word is like, and so like let's just not even have that be a thing. So right now we're going to go ahead and affix variable labels to each of these variables. Okay, so we started by typing variable labels. All right, make sure you spell labels right and make sure you spell variable right, because if you spell them wrong, SPSS is literally going to not know what you're trying to do. So now what we're going to do is we're going to take the new variable that we just created. Remember, it's this IMR 2012-2016. We're going to copy it and bring it down here and paste. Okay. And then in single quotes behind it, we're going to give it a nice label. Okay. Okay. Now you're going to put the like new label inside single quotes and put a period at the end. And something to know about variable labels is that there are a lot fewer restrictions on what you can do there. The only thing I recommend is just don't put an apostrophe in there or quotations, because when you put the apostrophe or the quotations in there, like SPSS thinks that you're closing out the label and it gets really confused. Okay, so variable labels, new variable name. Okay, remember that we just created it, and then we're giving it a nice label, average IMR 2012 to 2016. The label for that is going to be in single quotes, and then that line's going to end with a period. Okay, so once you do that, highlight it and then click the green play button up here on the bar. All right, that's run selection. Okay, now you have that syntax in your syntax window already, so you don't need to copy and paste it in there. It's already there. Isn't that nice? Look at you, like you're writing syntax. It's fantastic. Okay, so the next thing we're going to do is we need one final frequency because we want to make sure that we did this right, okay? Because there's lots of ways that this can go sideways, and I want to know that it's sideways right now as opposed to in 2 or 3 hours when I've been doing data analysis on this variable. So instead of like going through that onerous drop-down situation that I did before, I'm going to copy this syntax and paste it here. Okay. But you should know what's going on here. Okay. First, this syntax is on the original variable, which is IMR underscore 2012 underscore 2016. But that is literally yesterday's variable. We are on to a new jam. We are on to IMR 2012, 2016. So what we're going to do instead, and I don't need another frequency of this old variable, okay? I need a frequency of new variable. So what we're going to do here is we're going to double click this variable name, okay? We're not clicking and dragging because clicking and dragging just introduces the possibility of all kinds of errors. So we're just going to double click the variable name and copy, okay? I did that with Control-C. And then I'm going to double click over here and not be able to do it because I have all these underscores, which is super annoying. So we're going to copy and paste over that, okay? So we have a new frequency here asking for a frequency on IMR 2012, 2016, okay? Voila, okay? Look at how nice that is. So SPSS seems to have sorted out the number of decimal places situation. Like, look at this. Remember when this was happening and that was a nightmare? But now this new variable, IMR 2012, 2016, looks very nice. And it gave us a nice little like label here. See how it says average IMR 2012, 2016? Like, that's respectable. We could take that home to the parents to look at. This thing up here is annoying to look at, because there's all these underscores. IMR is lowercase when it should be uppercase. Like, ugh, gross. All right. So if your variables do not have labels on them, what will happen when you do a frequency on them and do any type of analysis with them is that you will see the variable name instead of the variable label, because there isn't a variable label. So that's why we always want to label our variables, because we want our analysis to look nice whenever we do it, right? This looks nice. I am not ashamed of this thing. This thing needs to get back in the back seat because nobody wants to look at it. All right. Okay. So that is the first variable. That's the first step that we just went through. Okay. Now you can like play around with some of the spacing here. You can take out all the hard enters. That's fine. It's not necessary that they be all spaced out. You'll probably find your own workflow that you like, and that is totally okay. But you want to have, you need to have these 4 commands in for each of your variables. I'm going to go through a couple more of these. I'm not going to do all of them, mostly because I think nobody really wants to watch a screencast that's going to be that long, but I'm going to go ahead and do kind of the rest of this. Now you can go back to I tell you what, I'm going to go back and go through this the way we did it the first time, and then I'm going to show you some super sweet hacks that are going to help you do it faster. Okay. So our next variable is going to be Forborn 2012 to 2016. The first thing we're going to do is we're going to ask for a frequency on it. Okay. And then at this point, like, we can just hit reset to clear out the window and then drag down to Forborn 2012, 2016, highlight it and put it in the window. Sweet. Okay. So again, like with all the excessive decimal places, there's like 7 decimal places here. Great. Kind of annoying. I'm going to go ahead and copy the syntax that just generated when we did that drop-down command and paste it into our syntax window. We're going to go up here to the transform window and click on compute. And again, we can just hit reset to clear everything out. We're doing Forborn 2012, 2016. We're going to highlight it and click this little blue arrow to move it into numeric expression. And then in the target variable window, we're going to give it a new name. I am nothing if not consistent. So I'm kind of going with the same way that I named the last variable, which was the name of the variable plus the year range with nothing else. Remember, in this space, the target variable space, this is a new name, which means it can't start with a number, it can't have any spaces, and for God's sake, do not put any crazy characters in that name. Letters and numbers, that's it, okay? Now, this is absolutely a place where you could put in an underscore if you wanted to. Okay, if you absolutely must, if you cannot help yourself, fine. But as you saw when I work in my syntax, like having a bunch of underscores in a variable name slows down your workflow because you have to click and drag to select the variable as opposed to double clicking. So it's just that, you know, that's the way the cookie crumbles. Okay, so I've got my new variable name in here. I've got my old variable here. I'm gonna go ahead and click OK. And, you know, the syntax that's generated for this is very like small. It's 2 lines of code and it's at the very end. So like, don't just like run it and be like, what happened? Nothing happened here. I didn't do it. Just first, slow your roll and scroll all the way to the end of the output. Secondly, like remember what you're doing here. All you're doing is you're computing a new variable. You haven't asked it for a frequency. I find a lot of people kind of get worked up and panicked because they do a thing and they expected to get a frequency when they did it, but they didn't actually ask for a frequency. So be sure that you're actually like understanding what it is that you're doing. If you just computed a new variable, that doesn't come with automatic syntax or come with automatic output for a frequency. So just know that. All right, so we've got our new compute command here. We've also got this variable labels command that we're supposed to do. And like, I'm all for just typing this out like I'm some type of genius, but I don't have to. I could just like take that syntax and copy it and paste it here. Okay, because all of this part is going to stay the same. These are the only 2 things that are going to get changed out. Okay, so let's start by taking our new variable, which is foreign-born 2012-2016, and replacing it with that. Okay, so variable name here, and now in the single quotes, we're going to take average percent of foreign-born. And I could probably even get fancy and put a comma on it. I do like the way that looks. Okay, something like that. And then we can highlight it and run it. And what's great about that is that the syntax works. We know it works because it worked up here, right? So what we did is we took the syntax that worked above in line 12 and we pasted it down here, okay? Now we kept the structure of it in place. We didn't change variable labels at all. We didn't change the single quotes. We didn't change the period. All we did was change out the variable here and the label, all right? And so that is a really nice way to make your syntax kind of like creating it speed up a lot, is just using syntax that already works and understanding enough about it to be able to quickly edit the syntax manually and create the analyses that you need. So once again, I'm going to just like totally steal this syntax from here, copying it and pasting it down here, right? I mean, this whole thing stays the same with the exception of the variable name, okay? So I could type it out, but I promise you that there's like 3 places where I'm going to screw it up by typing it out. I'm going to screw it up first by how I spell frequencies. I'm totally going to leave off a letter from variables, and I'm probably going to forget the period just by like typing it out. So I'm not going to try to do that. I'm just going to like copy and paste a frequency and then bring my new variable name for foreign-born 2012-2016 down here, copy and paste, and then run it. And then again, like remember that all of the work, all the stuff that you're hoping to see is actually going to be happening in a totally different window. Okay, so this is our foreign-born percent. Again, the decimal place has got itself sorted out. Here, there's one community area where over this time period, 60.07% of residents were foreign-born. There's one community area with 32.41% that are foreign-born. There's one community area that has 17.83% that were foreign-born, etc. Okay, look at the label. It looks really nice. Average percent of foreign-born 2012 to 2016. Let's look at this train wreck of the original variable, foreign-born underscore 2012 underscore 2016. Not nice. Okay, so that's why we attach the labels. All right, now I'm going to just like go split screen here because I'm going to speed this bad boy way up. Okay, so this syntax, I'm going to like copy and paste the whole chunk of it down here because I want to like take this into a new dimension with how fast this is going to go. Okay, my variable that I'm going to use for IV2 is NH_black _ 2012 _ 2016. So here I'm just going to make it for my new frequency. And then I'm going to also put it into this second spot on the compute command because that is what we're doing for this. This is the non-Hispanic Black percentage from 2012 to 2016. Okay, and even for this compute, we don't even have to delete the whole thing. We could just delete the foreborn. We could just do like NH Black. Okay, that's our new variable name. All right, so let's copy and paste new variable here and here. Okay, the label for the new variable can stay largely the same. We just swap out this situation. Okay, so what this variable is going to show us is the average percent in these community areas. It's going to show us the average percent of residents that were non-Hispanic Black. Now these numbers, the foreign-born and the race measures come from the American Community Survey, which you saw that when you were working in the Chicago Health Atlas. So that's where that data comes from. Let's double check our syntax here. We've got a frequency for non-Hispanic Black, and really annoyingly, it keeps doing that, like blowing up this window. Really annoying. Okay, so there's one community area where 0.4% of the residents are Black, non-Hispanic Black. There's one community area where 99.1% of residents are non-Hispanic Black. So that's the original measure, NH Black _ 2012 _ 2016. The next step is to make a new variable, and our new variable is going to be called NH Black 2012 2016. And again, we do compute new variable name equals old variable name. Okay, so let's go ahead and highlight that and execute or run, depending on how you think about it. The variable labels command, we're simply just attaching a nice label to this variable. And when you do it, it doesn't show you anything. It just like says, hey, I did that thing that you asked me to do. In order to see this thing in action, you have to do the frequency. Okay, voila. So here's the original measure. It has that NH Black _ 2012 _ 2016. Again, kind of a train wreck. Nobody really wants to look at that. This label, though, very nice. Like, this is something that you can be proud of, something that you look at it and you're like, oh, that's exactly what it is. You're not having to kind of go back and decipher what, all these things are. All right, excellent. So that's IV2. We're going to go ahead and copy and paste that syntax in for IV3. We're going to, this is the one where we're going to use the Gini coefficient. And simply just copy and paste away. And here we're making our new variable name. So we're computing Gini 2012 to 2016. It's going to be based on Gini _ 2012 _ 2016. Now remember, this is our new variable name. So like once we do this compute command, this is the variable we're working with. We're kind of like, we're ceasing to work with Gini _ 2012 _ 2016. Once we've created the measure, we're just Gini 2012 2016 from here on out. Okay. Now, in the label, this is like average Gini coefficient. Voila. Okay, and then we highlight it and run it. So our first line here was for the frequency on Gini _ 2012 _ 2016. ugly because it doesn't have a label on it and because there's 25 million decimal places here. Gross. So we computed the new variable, we made a new label, and then we did a frequency on the new variable. And look at this respectable looking variable. Like, this is the type of variable that you would be happy to be seen with in public. It has a nice label and it doesn't have 50,000 decimal places for each of these. So the interpretation here for this is that there are 3 community areas in Chicago that have a Gini coefficient of 64. There are 2 community areas that have a Gini coefficient of 54. There's 1 community area that has a Gini coefficient of 31. So pretty nice. All right, so that's Gini coefficient. Next one is per capita income. Love per capita income. So let's go ahead and copy and paste this command this code chunk, if you will, and grab per capita income. That's why we took the time and put all those into our comments. So we're just going to copy and paste. And make sure when you're doing this that you're being careful that you're not accidentally copying and pasting like just now. This is the second time I did that. I'm leaving out the G. So if I had not caught that and just went ahead and did this, I would get an error message because I'm telling SPSS on line 64, compute Gini 2012-2016, make it equal to G per cap inc underscore 2012 underscore 2016, which is a variable that does not exist. Okay, so just be careful when you're copying and pasting. It's super easy to screw it up. Okay, so once we do this command, this compute command, we are done with per capita income. We are just all per capita income all the time. So actually I need to do, you can go per cap inc. That's nice. Okay. So once this happens, we're only working with per capita inc from here on out. Okay. And then swap out variable name. Okay. Nice. All right. So again, the original measure has that ugly label at the top. The recoded measure is nicer. So there's 1 community area where the average per capita income is $8,425. There's one community that has a per capita income of $15,982, so on and so forth. So both the Gini coefficient, actually all of these variables in the mini project 2, we're going to cut these up a little bit because literally nobody wants to look at, this is not intuitive for us. It's not easy to understand what's going on here. Do tell me about the 1 community area that has a per capita income of $43,324. Nobody wants to hear about it. I would be really interested, though, in learning about all the community areas that have per capita incomes above $30,000 or below $20,000. So having the data here like this in its sort of raw form isn't always the most useful thing to look at, and that's okay. For our purposes, it doesn't matter today because we're going to ask for scatterplots, which are going to look hella sweet. When you see this, you'll be like, oh, this is art, okay? But you can't do scatterplots with anything but continuous measures. So this thing right here, continuous measure. These are all continuous measures. And the best way to look at these sort of relationships between 2 continuous variables is with a scatterplot. However, in the future, when we're doing, we want to know, what are the, are the north side communities, do they have significantly higher per capita income than south side communities? What's going on with that, right? So, that's kind of a nice little twist that we're going to be able to do. But for right now, just don't get too worked up about it. Yeah, it's not terribly intuitive or useful to look at it in the continuous form, and that's okay. All right, so we just did per capita income, and it's looking very nice. We need to do the last one, which was that no high school diploma variable. So make sure you copy and paste as we do. And this variable is, it's no HS dip underscore 2012 underscore 2016. And see how I'm about ready to, like, right here at the edge of this, I'm almost copying and pasting that parentheses. Ugh, like some type of amateur. So make sure you don't accidentally grab the parentheses. Copy. So we're going to do a frequency on that guy. Right. Yikes. Definitely questionable copying and pasting. And then, so that part's done. And then we're going to do the same thing here. We're going to just paste that guy in like so. And we're going to like change out the name here. The 2012 to 2016 can totally stay. That's okay. But we do need to update this part. Say no high school diploma. All right. Or you could just say no high school dip. That's fine too. Okay. But once you do this line, everything below that for this section needs to be no HS dip 2012, 2016. Done. Done. Okay. And then for the label here, average percent of residents without a high school diploma. Oh, look at how nice that's going to look. It's going to be so nice. All right, so no high school dip, no high school dip, no high school dip, no high school dip. No. Okay, good. So let's copy and paste all of those. I'm sorry, let's copy, highlight, and run all of those. Okay. So again, you know how Excel or how SPSS does with that original variable with 12 decimal places. Very annoying. Here's our final frequency, very nicely put together, only 2 decimal places. And then it has that nice label. It says average percent of residents without a high school diploma with a little comma in 2012 to 2016. It looks very sophisticated, guys. Okay, so the interpretation here is that there is one community area that has an average percent of residents without a high school degree at 49.64. Okay, or we could say on average 31.73% of residents in this community area do not have a high school degree. Or this sort of, you could even kind of like broaden your sort of phrases when you talk about it. So you could talk about like no high school degree as like low ed or low education. So you could say like in terms of low educational attainment in blah community area, whatever this is, 21.8%, 21.86% of residents do not, have this degree or whatever. So like you just have to play with how you talk about it. And, I'm very bad at talking with my mouth using the words. So like I always end up like kind of going in one direction and then my brain's like, oh, but no, don't do that. So always like sounds weird coming out of my mouth. But so when you're writing these, like at some point towards the end of the quarter, you're going to start writing these up and you're going to have to like talk about your results a little bit and just understand like that's easy as long as you know what your variables are. Okay. 100% know what your variables are. Okay. So, that's like great. The final thing we have to do here is we need some scatterplots. Okay. So it's going to be 5 scatterplots. Okay. And, it's, there are a couple different ways to do it and we're not going to get too worked up about it because like you can just play around with it if you like. But generally we want to have the dependent variable showing up in the y-axis and the dependent variable on the independent variables showing up in the x-axis. And we're going to do one for each combination of your variables. Okay. So we're going to go and I love doing this to my syntax because it gives me a chance to like scaffold out my analysis and like to kind of just make sure that I get everything that I'm supposed to do. So this is like a nice little reminder. You can even call this like outlining. Okay. and 5. All right. So for each of these scatter plots, the common feature is going to be your dependent variable. Okay, it's going to be the same. Like, so each of these scatter plots is going to have your dependent variable in it. And then the only thing that changes is just swapping out your independent variable. Now, in SPSS, you can get to the scatter plot function by clicking on graphs. And we can drag down to legacy dialogues and drag down to the scatter or dot. Okay. Now, we could definitely make this very complicated. Okay. We could do like this matrix scatter. We can do 3D. We can do an overlay. But we're not going to go there. We're just going to do a simple scatter. Okay. So make sure that you have it selected and click define. Okay. Now, the really lovely thing about the type of analysis and the type of workflow we have so far is that all of our variables are at the end. Okay, this is where they show up whenever you create new measures in the data set. So I'm going to simply highlight my new dependent variable. Like once we create all the new variables, we're working with those now. All right, so don't revert back and start working with this guy. We want to work with a new variable that we made because it's dressed up, it has a nice label, and it's going to be great. Okay, so highlight this guy and move him over into the y-axis. Okay, now our first independent variable that we want to work with is foreign born. We're going to go x-axis with that. All right, now we can put titles in here. We could like do like so. You can put a footnote in. I mean, you can just be as extra as you want here. And then for options, we're going to just leave this alone. Okay? And once you have your two variables in here and a label or a title on the chart, if you want it, that's fine. Go ahead and click OK. Okay? Look at that. Isn't that cute? It's so nice. I mean, I'm just like, I love it. I think it looks really nice, and I mean, it definitely does show a very, I mean, this is like IMR plotted on foreign born. Okay, so you could say there's a community area here, okay, that has an infant mortality rate of almost 5, okay, but it also has a foreign born rate of what, 4 or 5%. Okay, that's very interesting. So I think the great thing about scatter plots is they definitely give us the opportunity to look at our data in a very intuitive way. All right. So the syntax for it, though, just like any other syntax that we work with, right click on it and copy and bring it into your syntax window. Okay. Now, we could, like, there are definitely some things that you could do with the output. Like, you can double click on the output and do, like, all types of modifications, etc. So you have your variables in here, but you could change, all kinds of stuff in here. I don't know how to change any of it. I mean, I would just be guessing at this point. So right now it looks like it's like got the, oh, here we go. You can click on the actual points on the scatter plot and you can change colors. You can change the outline, whatever. Okay. So however you decide to do it is fine. Just when you're done, close it out. Okay. I didn't actually save it though. Okay, so you could highlight this, bringing this syntax into your syntax file is fine, but it won't recreate that scatter plot as pink, like with the pink dots like I had it. So it's not perfect. There is a way to do it with working with the syntax, but like it's definitely inside baseball, and I think a lot of you just don't care at this point. So don't be too upset when you like put the syntax in here and then you run it again and it doesn't produce the figures with pink, okay, or blue or whatever. I would say if that's something you want to do, that's fine, but do it at the end, like when we're getting ready, when we're starting to put all of the mini projects together, like run it again, then change all the colors on your figures if you want to, and then put those into your paper. All right, don't do it right now. Okay, so I'm going to go ahead and just paste all these code chunks in here because everything is going to be the same with the exception of one part of this. Actually, two parts because we have to change the label. Okay, so the second one is going to be, the first thing we did was IMR and foreign born. And we need non-Hispanic Black, 2012 to 2016. That's for Scatterplot 2. And we can even like help ourselves out here and say like IMR is foreign born. Non-Hispanic Black, 2012, 2016. Okay. And then we just paste over foreign born in this second scatter plot. Okay. The with part stays the same because IMR 2012, 2016 is the dependent variable. We want to keep that. Okay. And this part right here. Okay. And let's go ahead and run that just to see, just to confirm that it looks nice. Yes, very nice. Oh, man. And you'll know, like, it's very easy using this, like, copy and modify sort of method with syntax. If you ever, like, screw up and you forget to change the label, it's fine. Just go back and change the label and run it again. It works just fine, okay? So this is a sort of graphical representation of the average infant mortality rates and the percent of communities with Black residents. So not really all that surprising in terms of infant mortality in Chicago. The community areas with the lowest infant mortality rates tend to have the lowest percentages of residents that are Black. Community areas with the highest percentages of Blacks tend to have the highest infant mortality rates. Yeah, so in a twist that nobody was surprised by because it is a tough situation with infant mortality and race in the city. Okay, so, and you know, we could close out this output, but it's just going to run every time we run another code chunk. So don't close out the output, just let it run. All right, third variable is Gini coefficient, and that's Gini 2012, 2016. And let's come down here to like that. And we're going to like paste over that foreign born situation. Just like that. All right. Noise. Oh, wow. That is fascinating. Okay. So, Scatterplot shows, you know, the average Gini coefficient during that time period and the infant mortality rates. So infant mortality rates that are high, say like over 10, tend to be in community areas with Gini coefficients over 50. Kind of interesting. But then there's also like this little section here where Gini coefficient is really high, but very actually kind of low on the infant mortality scale. So that is going to be interesting trying to pick that apart. Okay, fourth independent variable is per capita income. We called that per cap inc 2012, 2016. And we're just going to like paste over that and go average per capita income. right, and highlight and run. Very nice. So, another graphical representation here. We have, to be kind of like maybe a curvilinear relationship, or, just kind of showing that infant mortality rates are highest in community areas that have low per capita income. And another twist that surprised absolutely no one. All right, and then finally our last IV was, the no high school diploma. Nice, that's no HS DIP 2012-2016. And then we just come down here and paste over, just like so. And then swap out the name here, or the label. Percent of residents with no, I say without high school diploma. Okay, and then highlight that and run it, and let's see what that looks like. Oh, a lot less like clearly defined linear relationship here. It looks like maybe could either be curvilinear like so, or maybe like, it's hard to tell. So we have like this collection of community areas that have low percentage of residents without a high school diploma and also have low infant mortality rates. They're less than 5 per 1,000 births. And then this section down here where there's high percentage of residents without a high school degree, but also with, relatively low-ish infant mortality. I mean, it's less than 10 per 1,000 births. It looks like there is a sort of big chunk of community areas in the middle where they have somewhere between 10 and 30% of the population that don't have high school degrees, but where their infant mortality rates are over 10 deaths per 1,000 births, which is intensely fascinating. So, all right, so this output file, we could keep it if we want to, or we could not. Sometimes it's nice to have it, but there's like, nobody really cares about it. We're going to generate, by the time we're done, that thing is going to be, maybe 1,000 lines long, and nobody wants to look at that. So if you don't want to keep it, that's fine. Don't worry about it. You can also choose to export it. Go File, Export. And you can always like save this as a Word document. And that is also nice too. You can kind of just keep that on your machine if you need it. I wouldn't recommend doing that right now because we're going to add a lot more content to this so that you can put it in your Word document and use that and turn it in for your course project. But you don't need to do that right now unless you just want to start putting your stuff in that document. What will go into the Word document is the 5 scatter plots that we made today. Okay, so that's going to go in the Word document, and then the syntax is actually going to be turned in separately with your course project. So that is that. I want you to submit your syntax to, well, first we're going to save it. Okay, I want you to submit your syntax when you're done with this step to the course website because I want to check to make sure that you're on the right track. It is very easy to go like kind of go sideways on this and then just end up really far away from where you're supposed to be because of just like some weird choices you made in the early steps, and I want to get everybody sorted out now. So when you are done with this part, make sure that you submit this syntax to the course website so that I can check on you and make sure it's okay. If you have any questions or concerns, please do email me. I hope this has been helpful. I really hate how long this document is or how long this video is. I'm so sorry, but I feel like you guys would rather have it be one long file than to have it be like 15, a bunch of like really short videos. So you can basically just kind of work right along next to me, go as I go, speed up when I speed up, and then, yeah. Okay. Good luck. Let me know if you have any questions or concerns. Thanks.